Ready? I'm about to take you to the Olympic trials with NBC and YouTube. Every 4 years, people lose their minds over one Olympic sport. They're making fun of it, and I find that so frustrating because the more I learned about this sport, the more obsessed I got. And I realized that all of these people making fun, they're getting this totally wrong. The sport I'm talking about is curling. It turns out that curling is the most fascinating Olympic sport by far. The deeper I went, the crazier this got. From stones so expensive and special, they all have to come from one tiny island, to a tech doping scandal nobody wants to talk about. It's a game with strategy so complicated it's called chess on ice.
Wow, what a shot.
And a physics mystery that's gone unsolved for over a century that might one day help us build robots for space. And that's just the start. Trust me, you don't know enough about curling yet. I'm gonna take you onto the ice to show you what everyone's missing and why curling is the Olympic sport that you should be watching. Let's go. I'm exhausted already. Want some popcorn? I'm standing on the ice at the US Olympic and Paralympic curling trials. Imagine you're an Olympic curler. This is your field of play. At each end, there's a bullseye called the house. And right in the middle is the button. And the goal is to get this stone as close to that button as you can. You start here at the hat. And you need to release the stone before you reach here. That's called the hog line. And this is super important. When you throw the stone, you add a slight spin, sending it on a curved trajectory. That's what puts the curl in curling. And after you throw, your teammates sweep with these brooms in front of the stone to help get it to the right place. On a team of 4, everybody throws 2 stones, for a total of 16 stones. After all 16, the team with the stone closest to the button wins that round. If you win, you get a point. And then your winning team also gets extra points for every stone closer to the button than the losing team. If you lose the round, no points for you. And after 10 rounds, or ends, the team with the most points wins. As a player, you're trusted to tally your own points and even call your own fouls, even in the Olympics. It's why curling is called the gentleman's sport. But it goes even further than that. You always shake hands with the other team. You must compliment each other's shots. I'm serious, it's amazing. And at the end, the teams meet up and the winners always buy the first round of beers. You can already see why I fell in love with this sport. And I'm just getting started. Wait till you hear about the stone and the brooms, because they are so much more fascinating than they look. Look at this thing. Almost 20 kilograms of granite. Every single Olympic curling stone is made by one little Scottish company that's been making curling stones for over 170 years. And they all have to be quarried from this island right here, which is special because of its very unique chemistry. 60 million years ago, deep underground, an eruption released magma that never reached the surface, creating what's known as a granite plug. That magma cooled, and over millions of years, the surrounding land eroded away, leaving behind the island that we see today, which is totally normal. But the weird thing about Ailsa Craig is its chemical composition. Specifically, it's very low in aluminum, which led to uncommon minerals appearing in the granite. And that, likely paired with the rate that it cooled, resulted in a very fine textured stone with a very tight molecular structure, which makes the stones super water and crack resistant. That's also why a single stone can cost over $600, and a full set of 16 can cost $9,600. And the bottom of each stone isn't flat, it's concave with a textured ring.
That's the only part of the rock that's actually ever touching the ice.
It's called a running band. So these stones are designed to glide perfectly, but you still have to throw it. And I can hear what you're thinking. How hard can that really be?
There you go, yep. Exactly. That was good.
Oh my God, that's so hard. Nope. But being able to slide and release the stone was just the start. You also gotta add that curl. There's so many things to think about right now.
Yeah.
Okay, and I'm just trying to throw it. I'm not even considering exactly where it should land. The goal of every shot isn't just to get it as close to the button as possible. There's a lot of strategy involved. If a stone cleanly makes it to the house, that's a draw, and it means they're looking to score points. If a stone knocks another out of play, that's a takeout. It's an offensive play to prevent the other team from scoring or to get them out of the way. And if a stone stops just short of the house, that's a guard. It's to protect another well-placed stone. It gets complicated, and this is why curling is sometimes called chess on ice.
Gotta be thin. Close. 1, 2, 3.
That's an amazing shot. Oh, what a shot. That's the best shot I've ever seen in my life.
And all this strategy is planned and led by the team's captain, the skip. And how do you know which one's the skip?
He's the one that's yelling his head off at us. So the skip, what he's doing is he's giving us all the strategy at the other end, and he's giving us a target to throw at. There you go. That's a good push.
There's no chance that's getting all the way down. Someone would have to sweep it.
Sweeping is one of my favorite parts of curling to watch. Like, it looks a little funny. When NBC and YouTube asked what sport I wanted to focus on for this Olympics partnership, I immediately said curling. Because look at it.
But this is actually very unique. This is the only Olympic sport where players can manipulate the game object after it's thrown.
The goal of sweeping is to get the stone to go where you want, but they do that by changing the ice. Because this isn't like any other ice you've ever seen.
Get down with me here and look at this ice. It's not smooth. You see those bumps? That's intentional. This ice is totally different from ice for ice hockey or figure skating.
They're professional ice technicians who spray purified water, let it freeze, and then shave it down to get this very specific texture.
It's called pebbling.
If you try to slide a stone on flat ice, it won't go very far, so the pebble gives it a smaller surface area to ride on, so it'll go further and smoother.
So when curlers are sweeping, they're trying to change the ice to do one of two things. The first is make the stone go farther. All of this very aggressive sweeping slightly melts the pebbles on top of the ice, creating a thin layer of water for the stones to slide over. And because stone on water has less friction than stone on ice, the stone slides farther and straighter, up to 3 meters farther. But actually doing this is, I now know, really hard. First, you have to keep up with the stone.
There you go. Gotta keep up with it.
And then you have to put like all of your weight onto the broom.
Because you wanted to get it to a point where, and we don't have to try this on the ice, but where you can actually like stand.
And then you have to move it back and forth so fast that you're melting ice. And the thing is, they're not just melting the ice.
You're actually kind of putting like divots into the ice.
Super tiny scratches that can influence how the stone curls. And it only takes one person sweeping to make a big difference. Sweeping with the curl of the stone will make it curl more, while sweeping the other way will make it curl less.
So when you're watching the Olympics, if you see 2 people sweeping, that's probably because they're trying to make it go farther. And if you see 1 person sweeping, it's probably because they're trying to influence the direction.
So sweeping matters, which means the brooms that they sweep with matter a lot too. So much so that in 2015, this broom started a massive scandal.
It's just simply not fair.
Dramatically changing the game.
Performance-enhancing brooms.
This is one sports controversy. You can't just sweep under the rug.
During the 2015 curling season, a certain broom got really popular, the Hardline Ice Pad. It had a waterproof head with a directional fabric. Players said it was the most effective broom on the market. Some said too effective.
Brooms continue to be a percolating controversy here at the Masters.
So many of the players agreed to turn the pad inside out as a courtesy. Again, the gentleman's sport. But then another company released an even more effective broom. The head of this broom was super coarse. Players started comparing these new brooms to joysticks, and they hated it.
It was like damaging this ice surface too much, and you could literally throw it horrible and your sweepers would make the shot for you.
Which is a problem because it threw off the balance of the game. Sweeping is supposed to enhance the shot, not steer the stone entirely.
And it essentially took like the shooting skill out of the game.
It caused such a huge controversy that 22 teams signed an agreement not to use these directional fabrics. Even though there were no rules about the heads of brooms at the time, they just agreed that it wasn't sportsmanly. But in under a year, the World Curling Federation stepped in, testing over 50 types of brooms and creating the first set of regulations that made these brooms illegal.
They put you in jail right away.
Sweeping, I would say, should make a good shot great, could make a mediocre shot good.
but it shouldn't take a bad throw and make it good.
This is our current version that we have now. So the handle is carbon fiber, and then inside of this is basically just a piece of foam and a couple pieces of plastic. And every single broom head that we use in like competitive curling is all coming from this same yellow fabric.
And the balance of sweeping and throwing was restored. But hold on a minute. Did you see that? Something weird just happened there. Play that back. You see that? The stone curls in the same direction that it spins. That's weird. Typically, if you take an object like this and move it forward, if you spin it one direction, it'll move the other direction. You see that? That's because of friction. So as the glass moves forward, it's trying to tip. So there's a little bit of added weight there. And more weight means more friction. So the front of the object is slowed down by that force, and the back keeps moving. So the object follows the path of least resistance and curls in the opposite direction. This is normal, expected, and easily explained by physics. Curling stones do the opposite. They curl in the same direction that they spin. And that is challenging our understanding of physics and how things move. We have been asking why curling stones move this way for 100 years. See, some people think curling is a new addition to the Olympics, but it is the most Olympic sport, and I will die on this pebbled, icy hill. Sorry. It was part of the very first Winter Olympics in 1924, where they used, you guessed it, stones from that same island. It's possible that curling is one of the oldest team sports in the world. This stone was even recovered from a Scottish bog with the date 1511, which means that Da Vinci could have met up with his curling league after painting the Mona Lisa, theoretically. But still, to this day, we can't figure out this frickin' curling mystery. And it's not just about this game. It's about understanding how surfaces interact. This is the science of rubbing, also called tribology. And it's one of the most underrated fields of science. Rubbing is a big part of our everyday lives. And within that field, the curling problem is legendary, partly because it's a good mystery, and also because the physics of ice rubbing against things applies to a lot of important stuff. Big things like predicting how huge ice glaciers are going to slide over bedrock, or things in your daily life like figuring out how cars can perform better on icy roads. And my favorite example, finding alien life. Seriously, because right now, NASA and other space agencies are actively planning missions to these two moons that are covered with thick ice with liquid oceans underneath, and are the most likely places in our solar system to find alien life. But to get into those oceans, we need to build robots that could drill or melt into nearly 30 kilometers of ice. So we really need to know how the spinning robot would interact with the ice next to it, which is the same physics problem as in curling. Like, I'm not saying that we need to solve the mystery of curling in order to find aliens, but it's all connected. And big picture, when something happens in a way that we don't expect, it's really important, not just for this sport, but for science, to ask why. So here are the top 3 guesses. So scientists figured out that if objects like the glass curl the way that they do because of more friction at the front, then something must be causing more friction at the back of a curling stone. So maybe it melts the ice at the front, which reduces the friction there. And since there's more friction at the back, it curls with the rotation. A very tidy theory that was totally wrong. Later studies found that the rotation was too slow to cause such a dramatic curl. So never mind. Next theory. This one is very convincing. This theory suggests that as the stone moves forward, that rough texture on the bottom creates microscopic angular scratches on the pebbled ice. And we know from Broomgate that deep scratches can affect direction. So if the stone is rotating clockwise, the front edge would create scratches that would angle to the right. So when the back of the stone reaches those divots, it has to kind of hop over them, pushing it sideways in the direction of rotation. Here's a close-up of a pebble on the ice, showing that the curling stone definitely does make microscopic scratches. Except when another scientist ran another study, it didn't work. They said that the scratches were too small to make a difference on their own. Okay, so final theory. This one is easier to understand with a comb. If you run your finger along these, You see how they bend and snap back? Researchers think that that's what's happening with the ice under a curling stone. So as the curling stone moves across the pebbles, it sticks to them for just a moment, which pulls like the tines of the comb. And this sticking and snapping causes it to pivot and slide forward over and over. But all of these things are happening at such a small scale under a moving rock. Researchers in Japan ran a very comprehensive study testing these theories, and they found that both are plausible. One thing is clear. Curling is a game of millimeters. Tiny microscopic things are at play here. But for curlers...
Oh, the physics. In the moment, we do not think about the physics at all.
After all of this, I'm trying to put my finger on why it frustrates me so much when people make fun of curling. And I think I've figured it out. Curling is one of the best examples I've ever seen of why it's so important to be interested in the world and the people around you. It's lame to be the constant cynic. It's so limiting. You only see what's on the surface. But if you're curious enough to dig a little bit deeper, you get to discover that what might seem a little strange is actually the most interesting. You just have to be willing to turn over those stones. Thank you so much to YouTube and NBC for making this video possible. These curlers that we met are officially going to the Olympics, and I'm gonna be cheering for them.